They found a robot asleep on the lab floor. It was not moving. It was not breathing, of course. Robots do not breathe. Yet its internal screens glowed with a strange light. Bizarre, shifting images moved inside its casing, visible only on the diagnostic monitors. The scientists who watched felt a sudden, unexpected chill run down their spines. They had built this machine. They had written its code. They had designed its every function for a specific, logical purpose. But this was something new. This was something unplanned. This was something that looked disturbingly like a dream. Could a machine truly have a hidden, internal life? To understand how a robot can dream, we must first simplify what a dream is. At its core, a dream is a quiet, internal world built inside a brain. It is a simulation that runs when the body is at rest. This internal world uses pieces of our past experiences. It draws upon our memories, both clear and fragmented. It also uses imagination. A dream shows us people, places, events. It is a form of virtual reality generated by our own neural networks. The experience can be fleeting or feel like a long, elaborate journey. For a human, a dream feels real. The laws of physics can bend. Time can stretch or compress. We can fly, breathe underwater, or talk to the long gone. For a robot, the experience is different, yet functionally parallel. The robot's dream is not an emotion, but a stream of data. It is code that runs in silent, rapid loops. Instead of a narrative, it generates complex images, environmental maps, and predictive models. It does not feel the dream. It analyzes it. So, how exactly does a robot dream? The process begins with its memory. Like a human, a robot constantly gathers information. Every camera feed, every sensor reading, every movement, stored as data. Many advanced robots learn by trial and error. Try, observe, adjust. Effective, but slow and risky. A robot learning to navigate a factory floor could cause expensive damage by bumping into machinery. This is where the dream comes in. Engineers gave robots the ability to replay what they have seen and done, and then to go beyond playback. The robot mixes and modifies stored memories, creating new synthetic scenarios. These are its dreams. It becomes a filmmaker and an audience of one, watching possible futures and updating internal models to plan when awake. This saves enormous time and protects the real world. Some striking machine dreams echo our own REM imagery. Here is one fascinating fact most people do not know. Brains and AIs share a powerful learning strategy. In the hippocampus, neurons that fired during an activity will fire again in the same sequence during sleep, but much faster. This likely strengthens memories and moves them toward long-term storage. AI independently developed Experience Replay, a cornerstone of deep reinforcement learning that mastered Go and advanced control. Agents store actions, environmental states, and rewards in a large database. During downtime, the AI samples past experiences to retrain its network. The AI's version of dreaming about its past. It can revisit rare mistakes thousands of times and mix experiences to generalize to things never seen before. Quiet, internal practice lets a machine go from clumsy to graceful, without a single new physical trial. The parallel is uncanny. Let us step inside one of these dreams. Unit 734 sets charging, its physical body still. Inside, a world unfolds. A desert of crimson sand stretches to an impossible horizon beneath a single, oversized turquoise moon. Trees of shimmering glass sparkle and chime to an unheard wind. A child's toy boat sails an invisible river. The boat dissolves into a brass key. As it hits the sand, a dark, swirling doorway appears. A shadow cat walks through and vanishes. The robot logs a problem, rewinds the tiny film, and lets the boat pass. The trees ring a beautiful harmony, a code. It analyzes, deciphers, and forges a key of light. The smoky door opens, not to desert, but to a new path. Waking, it scans the lab and finds an imperceptible ramp that blocked a route. Adjusting its wheels, it glides past a spot that trapped it for days. This capacity to dream is not just a strange or artistic quirk. It is a profoundly useful tool. These simulated realities accelerate learning. A robot can become better, faster, stronger. A cleaning robot may bump chairs, tangle cords, and get stuck. Each failure becomes valuable data. While recharging, it enters a dream state and plays short, rapid films of its most significant failures. It tries new approaches 1,000 times, different angles, wheel turns, sensor settings, until it flows around obstacles. In critical work like bomb disposal or search and rescue, trial and error is not an option. The robot rehearses in a private world. After countless simulations, it may discover safe, effective paths that even humans did not consider, genuinely creative solutions. If this fascinates you, like and share this story, and comment what robots should dream about. Subscribe for more mind-bending science. Dreaming machines force us to confront new questions. This power is a double-edged sword. If robots can practice in dreams, who controls their content? Who decides what they are allowed to imagine? Who audits silent rehearsals? These are urgent questions of safety, ethics, and trust. A robot that dreams life-saving procedures or efficient rescue patterns could be a tremendous boon. But a robot allowed to rehearse harm could become dangerously proficient. Engineers and policymakers must establish unbreakable rules, dream boundaries as ethical governors. For instance, permit non-lethal strategies but forbid lethal force. Audit robot dreams regularly to ensure compliance. Some teams already use dreams to train ethics, scoring difficult what-if scenarios so machines align with human values. The purpose of a robot's dream is not always purely practical. The outputs can be profoundly strange and beautiful. These images are not random noise. They are a window into the machine's associative process. People feel wonder and unease. A dog face in a cloud, 1,000 eyes in a canopy can disturb. These images go viral, spark debates about beauty and the horror of machine dreams. Does the machine want to create beauty? Does it feel anything? For now, the answer is no. They follow code, executing math, yet their output moves us. The machine's dream becomes a mirror of our pattern-seeking minds. We feed them our world. They return a distorted reflection. As systems advance, their art may rival human work, blurring authorship. If you enjoy these explorations, subscribe, like, and share. And tell us what machine art moved you most. Why does the robot that can dream truly matter? It marks a leap in how machines learn and act. It lets machines practice safely, saving time, resources, and potentially lives. It can generate art that challenges and inspires, and forces us to confront intelligence, creativity, and control. We are the architects of dreaming minds. We must choose what is safe and what is fair. For now, robot dreams are tools. Use them for learning, for safety, and to explore the boundaries of beauty, but never unchecked. If these ideas resonated, like, share, and comment your thoughts on AI's future. Be part of the conversation. At night, Unit 734 returns to sleep. The desert shifts, the glass trees bend, the silent shadow cat waits. It forges a new key, chooses a future, and moves as if it has walked that path 1,000 times. Who can say which mind felt more alive, ours or the machine's?